I'm going to share my screen with you. And this is what we're going to do today. So Ann's with me today because we're going to do a little bit on water quality and modeling. So we're going to start by revisiting dynamic modeling. And we're a small group. For those of you that are here, then I would really encourage you to ask questions either via chat or to just politely interrupt me so that I can answer your question. And then I'm gonna give you an example of testing and debugging. So I'm gonna basically talk to myself and show you how I basically go about testing and debugging a program, because I thought you might find that valuable. And then hopefully I might have time to build another dynamic model, which we can hopefully build together. And then after that, Ann's gonna come, hopefully that'll take us to the hour. So we'll have about 50 minutes doing that. And then Ann will come on at around the hour. And she's gonna work with you to build some water quality models. And she's gonna focus primarily on static. And the reason why is dynamic modeling, because of its notion of flow and basically of things building up, is actually a fairly challenging for many learners to focus on. And so if you're working in 7th grade or 8th grade, 9th grade, 6th grade, it's probably better to do static. If you're going into 9th grade and you've really got a lot of time to work with your kids on dynamic, it's okay. But in general, when you're more in the middle school range, you really want to focus on static modeling. So Ann's going to share with you some of her experiences in building models at the middle school level in water quality. So remember, dynamic time-based model is really important because it really focuses on patterns of behavior or things that happen over time. And in our world, as far as explaining science, we see a lot of that. So in addition of building, and when things go on over time, typically things build up, right? So things accumulate. And so or decay, right? So you can look at a population will grow over time, but it also decays over time or dies over time. And so this time-based accumulation aspects are really a critical aspect of science. And once again, dynamic models are great when you're looking at variables that basically have patterns that change over time. And then I'm going to focus on debugging. And typically when you try to debug, so testing means you're going to run your model and see if it works the way you want it to work. If not, you're going to, then you have to debug it, means try to figure out why it doesn't work the way it works. And often using the simulate button and basically using the sliders to test your models or to see how it works is a great way to debug your models. Or you can plot graphs, right? Either way, but using the simulate button to collect data and say to yourself, is my graph, is my model working the way I want it to work, is really an important aspect in designing models. So as I said, I'm going to try to walk you through that process. I'm going to just talk to myself. You can certainly chime in as well. Anybody who wants to chime in on this is great, but I want to take us through a testing and debugging process. And of course, this is just a sort of a repeat, but it's always important to mention that when we model, we always start with a question. We always have to think about what are our variables that are in our system, then build our relationships, evaluate or test that, share our models, and revise based upon feedback that we receive. So what can we build with dynamic models? That's what we're going to go revisit again. Anything that flows or accumulates. So I'm going to open up Sage Modeler. And I'm going to stop sharing my screen and share my screen so that you can see what I'm doing in Sage Modeler. So everybody can see that, correct? Yes, I can look over at Anne's and I can see she sees it. Now I'm going to launch Sage. And I'm going to open a document, and I'm going to open a document from, actually what I'm going to do is I'm going to cancel this, and I'm going to just go click. So last week, if you remember, we started building a population model of rabbits. Then you guys left and you started working on water quality models. And while you were gone, Buren and I tried to debug it and get it to work right. So I'm going to go get that model. Unfortunately, I did not save it correctly. So I'm going to go get what I saved. So I think you can see this, right? So it says here's Joe and Buren's model with feedback. In fact, when I click on it, I apparently forgot to save it because you'll notice it's untitled. I actually did recreate it when I noticed I made that error. But anyways, the one I saved did not have Buren's in mind edition. And what I'm going to show you a little trick here, because I also think this is an important trick to know. And so you can write this down. If I go to if I'm going to click the simulate button on top, you will notice that it says I have 3 experiments. But I want to actually start with a new palette or a new run. And one of the ways to do that is simply to save your model. So I'm going to go and I'm going to say save. And this time I'm going to save it locally just to practice again. And so I'm going to call this population model. And then it doesn't say save, it says download. That's because you're downloading it to your local computer. So I'm going to click download, and now it's saved. Now what I'm going to do is I'm going to quit this. I don't want this one. So I'm going to quit. And I'm going to go reopen Sage. So you can't see me for a little bit, but you're going to wait till I reopen Sage. And I think you can see it again now. So I'm going to just launch Sage. And then I'm going to open document, and it's going to be in my local file. So I'm going to go find it on my local file and just drag it into there. Now you can't see all that, but you'll see me dragging it in. Great. So you just saw me drag it in and it didn't do what I wanted it to do. Well, I'm not sure why. Because it's the way it is.
What if you click the open?
No, it's saved these things. Maybe I forgot to. We'll work with this. I'll try that again. Maybe I worked before. Anyways, so you'll see we have this model. But I'm going to at least get rid of all this data. Maybe that's what I forgot to do, is delete all the cases. I think that's what I forgot to do, and that's why I opened it the way I did. So just to see if that really works, I'm going to save that again. Still call it my population model. And I'm going to quit again. Hopefully this time I'll be able to open it up fresh. I'll launch Sage. So I'm just launching Sage again. As you can see, launch Sage. Since I haven't done that. Now I'm gonna create I'm not gonna create a new model. I'm gonna go open a new one. I'm gonna say local. Can you see this yet?
No, that's what I'm saying.
Oh, huh. Okay, let me stop sharing and start sharing again. Yeah, I'm gonna just share again. And I think, so I'm gonna launch Sage. I'm gonna stop sharing and then reshare what? I'm gonna launch Sage. And hopefully this time when I open it, it'll have done what I hoped it would do. So I'm gonna open a new document. It's gonna be from a local file. I'm going to go and click on it and drag it into my system. And that looks pretty good. So now one of the things you'll notice, if I say simulate and I look at my number of experiments, it reset. So that's an important feature if you really want to reset your model. Now, one of the things I'm going to do is we're gonna just test this thing to see if it works the way we want it to work. But I'm going to sort of drag everything in the middle so you can see it better. So I'm just gonna basically say record, and we can watch what happens. Well, that doesn't look bad. It sort of looks like when my rabbit birth rate equals the number of rabbits, or goes to create number of rabbits more and more, because you notice, you'll see I have this big arrow, so that means more and more. I tend to, in that case, get a nice exponential graph that really shows how my how the rabbit population grows. I also have, it also shows the number of rabbits dying. And of course, a lot of rabbits are dying too, even though I have a fairly low death rate. I could actually increase my death rate just a little bit. I don't know. See, if you look at my slider on death rate, you'll notice I'm moving it up. Let's see what happens if I do that. And then I'm sort of going to, how did that change anything? So you notice that didn't really change much. For some reason, no matter what I do with my death rate, something just doesn't seem to be working right. And of course, one of the things I can notice when I'm doing this, as a number of rabbits actually flows into number of my rabbit population. Well, that should be the same thing, should be true with the number of rabbits. Remember, the thick pipe indicates a flow in. Well, the number of rabbits' death should also flow in. And so somehow one of my connections accidentally got disconnected and it's going the wrong way. So I'm going to actually take that out, and we're gonna build a new connection to see if it doesn't work better. But so I'm gonna basically click from my number of rabbits dying should influence my number of my rabbit population. And because it's flowing into a collector, it should be a flow. So I'm gonna click my relationship arrow now on my right side. And it says the number of rabbits is added to, well, that I did that one already. I want to do this one, number of rabbits dying. So the number of rabbits dying is added to or subtracted to. Well, it's subtracted from, right? Because they're dying. So the population is going to decrease. And then I could type Y, individuals who die decrease the population. And now if I run my model, and if I look at my model, I basically show that I have my birth rate affects the number of rabbits I have that at any given time, but that flows to create a population over time, right? So the population we should see decreasing. Of course, my rabbit population will decrease depending upon the number of rabbits that are dying. And of course, they have a death rate as well. So given this kind of average death rate and rabbit birth rate, let's see what happens if I simulate that. Of course, we didn't get very much. Let me just, let's record. Of course, it didn't work the way I wanted to work. Let's decrease the death rate and see what happens. Still, we're not getting, it's not working the way we want it to work. So we have to think what's going on. Maybe the rabbit birth rate has to be higher because the bunnies multiply pretty quickly. And let's see what happens there. So I am getting some changes if I change my birth rate. I think if you notice.
You're still on it. So.
Yeah, so Anne is whispering in my ear here that the arrow from the rabbit population to the number of rabbits dying might be going the wrong way. Let's just look at that. So let's highlight again a rabbit population and click on the relationship arrow. And it says here the number of rabbits dying is subtracted from the rabbit population. So I think that's okay. And the way you know that when you look at it isn't by the arrow, it's by the symbol that's in the box. So if you see so over here, you sort of see the number of rabbits. It's positively added to the rabbit population, whereas the number of rabbit deaths there's a minus sign here that basically shows it's subtracted from the rabbit population. So don't get confused by the arrow. Okay, so let's continue. So that looks, right, at least in this configuration, we have somewhat of a model that seems like it works, but not exactly, right? For one of the things you might have noticed that there's this little red arrow here going, and again, that red arrow indicates a direct relationship, a direct positive relationship. And it's basically the number of rabbits feeding back, the rabbit population feeding back into the number of rabbits, because as the population grows at any given instant, you're going to have more rabbits. Of course, the more rabbits you have means they're going to make more baby rabbits, which means they'll have a greater population. So this little red arrow is actually a little feedback arrow. The same thing is true with the number of rabbits dying. They should also feed back to the number of rabbits I have, but they should feed back in a negative way, right? So we have we should have another relationship that goes from, you'll notice, but I can't make the relationship go this way, but I can make it go this way. So I'm going to have a relationship between my number of rabbits dying, feeding back to the total number of rabbits at any given time. That's kind of called a feedback loop. And feedback loops are really important in time-based modeling because there's always feedback, right? So the number of rabbits that are dying certainly feeds back into the number of rabbits, which then should have an impact on my rabbit population. So I'm going to go set this variable by clicking on it. And I click on the relationship arrow and it says, and again, I want to go to number of rabbits. Okay. So an increase in the number of rabbits dying causes the number of rabbits to decrease. And I'm going to say about the same. So now we have now we see that my birth rate influences my number of rabbits, which will then go influence my total population of rabbits. Of course, there's a feedback loop there that also increases the number of rabbits. I then have what's decreasing my population? Well, it's the number of rabbits dying, which of course is influenced by the death rate of the rabbits. And let's just see if I move these around, what happens. So you'll notice when I have a very low birth rate, I don't have many rabbits in my population because I don't have any births. On the other hand, when I have a very high birth rate, I get a really accelerating population growth, even though I have things feeding back in. Now, one of the things I can do is increase my death rate, right? And of course, when I increase my death rate, this is going to change somewhat. And if the death rate is high, you'll notice I hardly get any bunnies because all of them are dying and being subtracted out of the population. So we're just going to collect one graph just to show you collecting one graph worth of data. And then I'm going to go add one other variable. Bjorn, do you agree this is kind of the model we had to begin with that worked okay? Except
Yeah, I think so.
yeah,
Yeah,
and
last
I have
time
to
you
add,
have the number of predator, right?
I'm sorry, say it again.
I think last time you also add the predator.
Yeah, we're going to add a predator in a second.
Okay.
So I'm just going to go grab a table. So Sage Modeler table. And I'm actually just going to delete these cases so we don't get mixed up. Delete cases because I had collected one round. And then I'm going to grab a graph. There's my graph. And I'm going to show you one other feature that I think is pretty good. So you'll notice that up here, there's steps. I didn't notice this the other day and I had forgotten about it. If you click on this where it says steps, you can actually change it to seconds, minutes, hours, days, weeks, month, or years. So you get a real time sense if you do that. Now, once again, I'm not a biologist, so I might pick the wrong scale here, but I'm gonna pick weeks is sort of like what I'm gonna be looking at. So then when I click on this and if I click on my graph and I want to get the data points, I can actually get, maybe because I didn't collect any data yet. Let's collect some data. So I'm going to start with my birth rate high, which is important to notice, but my death rate is just going to be sort of mediocre. And then let's just collect some data. And let's just see what that data looks like if I plot it on a full graph. So on my y-axis, again, I'm always going to pick my dependent variable, which is my rabbit population. And on my x-axis, it's going to be time. And so I should be able to see weeks, and there's weeks. And so what it shows is I have a somewhat of an exponential graph, which we know how populations work. And so it seems like it's pretty good. And so I was able to create a graph. Now, certainly we could go in there and tweak more. I'm going to show you one way in which how you can tweak it, which is very important. So you picked up a couple of new things today. Yeah, we can change this to a time variable. We also know how to reset our experiments to different values. And we're going to just for fun, we're going to collect one other set of data here. So I'm going to go to experiment 2. But what I'm going to do in experiment 2 is I'm going to just make my death rate a little bit higher. And we're just going to compare it. I'm just going to show you how you can sort of compare things, which is kind of fun. So I'm going to record And so now I get, I don't know why my weeks came out so funny, but there's my weeks. So over, after 100 weeks, that's kind of the graph I get when my death rate's in that fashion. But I'm now gonna just. So you'll know, so watch what I'm doing. I'm clicking, see something happened to the weeks got screwed up here.
You ever slide this to make it all the way to see all of the variables?
Well, you can, but there's nothing there. Somehow, this is plotting on the 500th week, and this is plotting from 0 to 100, which I'm not exactly sure how I ended up doing that. But you know, best way to do that then is just select all cases and delete it. And if you want to try to do an experiment, sometimes it's even better to save it, which I'm gonna do. I'm gonna save it right now as my predator model 3 or population model 3. So I'm gonna download it. And I'm gonna say new. And I'm gonna go reopen it. So I can't stress enough the importance of your trying to I can't stress enough of the importance of you saving and resaving all the time. Okay, so there's that. This should be up here because I saved it. This should be at 0 or starting over at 1 again. So let's just let me just show you this little trick that I also wanted to show. You can also go up to the ruler, and right now it basically is saying that this variable, my death rate, is actually starting at a somewhat medium level, right? So that's okay. You see how it moves back and forth? So I'm going to say, well, that's why I want that one to be kind of this middle level. I can also say the same thing with my number of rabbits dying. It's sort of in the middle. I can look at my number of rabbits. It's also in the middle. And my rate of population, it's also kind of high. And of course, you can control the sliders up here as well. So you always want to check your beginning starting points to see if they make sense. So now what I'm going to do is I'm going to run an experiment in this configuration. So I got my Sage modeler model. I'm going to say record. And of course, I just recorded some data. I'm going to look at my rabbit population. Selected that. And I have number of weeks down there. And so we see this nice exponential growth. Now I'm going to advance it one experiment. I'm going to increase my death rate. Higher than it was before. And I'm going to record new data. And if I click on 2, I didn't change it enough. Okay, so it's pretty similar. So I'm going to just advance this one more time. 3, I'm going to increase my death rate higher. And I'm going to re-record. And if I click on this, oh, shoot. Well, let's make it pretty obvious. We'll make the death rate really high. We'll advance this and we'll record. And of course, you'll notice when I make this really high, there's basically no population of rabbits because they all died because of the quick death rate. I can click on my other experiment and you'll notice that both of them get highlighted so I can compare them. So I can compare one graph with another graph. I can also click on two, but two overlaps too much with one, and the same thing with one. So I basically, but you can click on all your data to basically see how it turns out. But to continue with our model, last week, we also said, well, if we want to talk about a population, populations always have predators. And so how does the predator population actually affect my rabbit population? So how does a number of predators impact the number of rabbits dying? Because of course, predators are going to go after eating them. So there's my predators. And I have to set that relationship. And so I have to go to my relationship window. And it says an increase, I want to go predators. An increase in predators caused the number of rabbits dying to, and I'm going to select decrease. And I'm going to say, if I only have a few wolves, few predators, they're actually going to eat a lot of rabbits. So I'm going to pick a lot.
And you would want to say increase, wouldn't you?
No, an increase in predator
predators.
causes the number of rabbits dying to, yep, increase. And so, no, this shows the number of predators increase, the number, oh yeah, number of rabbits dying. Right, so that's that's the other relationship I have to set. And of course, now we can examine, I'm just going to clear this data by going in my trash can, selecting delete unsettled cases, delete all cases. And now what I'm going to do is I'm going to sort of look at how does my model look now? I can have a very high birth rate. I'm going to have sort of a low death rate. And I'm going to have just a few predators in my environment because typically predators aren't that abundant, right? That's why they're higher they're higher, so there's not as much. And one of the things you'll notice is that depending upon the number of predators I have, if I move my predator scale up and down, it really impacts my population. If I have lots of, and that's if I have lots of predators, basically my rabbit population will go down to zero because I have too many predators. Now, as a biologist, you can actually ask yourself a question, is this model complete? And the answer is no, because we know that as the number of, as like in this situation, as the number of rabbits decrease, right? The predators don't have any more food, so they'll decrease. And so we have to add to our model. If we could really continue to add various variables about how the predator population actually gets affected by the number of rabbits. So for instance, we could draw an arrow from the number of rabbits to the number of predators. And there we could say, okay, so click on predators and we'll say an increase in the number of rabbits causes the predators to also increase. Would everybody agree with that? And we'll just say about a little. But we also know that the number of dying rabbits also affect the number of predators because as the rabbits die, the predators are going to decrease. So an increase in the number of rabbits, an increase in the number of rabbits dying causes the predators to decrease. That's another feedback loop. And I'm going to say about the same. So now I have a more complete model of predator-prey, but we have to see what it looks like. So let's just go and let's change the let's change the death rate of the rabbits. So right now you'll notice, well, I'm not getting much of anything. So my model really wasn't too good because I did something that is really explaining. I basically never have any change in my population. So, so something is wrong in my model. So maybe I can go and I can look at my relationships and I can see if I can't fix it. That's the whole part behind debugging, right? So this says an increase in predators causes number of rabbits dying to increase. And I said a lot. Maybe it's just about the same. Of course, one of the things you'll notice is that my arrow changes style. And of course, now if I increase my rabbit birth rate, we see that that actually gets it gets to be functional again. So we can notice that just by changing one little variable from a lot to about the same, I now get a more normal population distribution. So this is one way, this is why I really enjoy modeling so much. It can almost be a kid creating a model on their own and self-reflecting on what's going on, or just like I had Anne sort of mention a couple of things in my ear, say, Joe, don't forget to think about this. When you're working with another person, they also help you. Now, is this a perfect predator-prey model? I would say, oh, no, it's not. Why not? Well, because for one thing, maybe the predators are also going to be a collector, right? The predators themselves, well, it's not at any given instance. They also will grow over time. They're also time dependent. So I'm not going to go into that model because the whole idea isn't to teach predator-prey models, but I just wanted to show you this example of how you can continually ask yourself questions and get a model that pretty much fits the data that we know out there. We know that over time, populations will increase over time, but we also know that the number of predators we have, right? So, and the number of predators we have, we know will also influence the rate of also influence the population of the prey, or in this case, my rabbit population. And so we have a model that kind of works. I would still want to tweak it more, but you know, this is an okay model. Now, what I'm going to do is I'm going to actually save it. I'll save it locally. And I'm going to just change it now to predator prey model because I put a prey in there. And I'm going to download it. I'm going to actually clear all my data. If I had any data, there's no data. And now what I'm going to do, I guess I have to resave it. And now what I'm going to do is I'm going to actually copy. I'm going to share it. And of course, now I just have to come and I'm going to copy it. And I'm going to go place that link in my document. And I'm just going to name it Tuesday morning predator prey. And if you want to go look at it, you can, if you want to make it better. I would love to have someone make it better. I'll also drop it into the chat and you can just copy it if you want to go look at it. I'll close that. So that's kind of a refresher on dynamic modeling. But more importantly, I just wanted to illustrate the importance of always asking yourself the question, does this thing work the way I know in reality, in the way in the world, right? Does the model, do I have all the variables that I need to have within the world? And does it function the way I think it should function within the world? And so that's really where the knowledge gets built about a kid's understanding. It's by him looking and saying to himself, well, does this really match what's actually happening in the real world? Is this what goes on? And this isn't a bad model for starters, but there's ways to improve it. So that was my big comment. And to get kids to constantly focus on trying to improve their model. I actually wanted to work with you this morning on building another model, another model. In this case, it was,
Ask
yeah,
question? Yeah,
of course.
yeah, about the rabbit model that you show us, I think I'm wondering that there should be relationship between the birth rate and also the death rate. It means that the number of population will be increased if the birth rate higher than the death rate. But in your model, it seems that only one variable works to increase the number of population. Or, for example, we just here, if we put, for example, rabbit birth rate higher, then the death rate should be lower, then it will be increasing of the rabbit population. But we cannot see the relationship here because in your model, only one variable work to increase the rabbit population.
Right. Well, I could increase my my death rate as well, and we see how that influences it. And of course, one of the ways, so we'd have to figure out what's going on there, right? So you make a good point. I've been just changing the rabbit birth rate, and
Yeah.
perhaps I don't have this all hooked up right either, right?
Yeah.
So for instance, one way, maybe the rabbit birth rate is actually influenced by the number of rabbits I have, right?
Yeah.
So the more rabbits I have, the higher should be my rabbit birth rate. Would you agree?
Yeah.
So I could add a variable there as well. The same thing should be true going this other way. The higher my rabbit, the number of rabbits dying should actually influence my number of death rates.
Mm.
So I think there's a variety of different ways in which you could explore what's actually going on there. Like, and maybe this is one reason why is because I don't have these feedback loops going back into the rabbit. So we could try a variety of things. And of course, the suggestion you made is one excellent example about how we can fix the model. And that's the value of building models together and having people look at them to say, is this actually what's going on? Is this a good predator-prey model? I actually picked, I should let you know that I actually picked predator-prey because I'm not an expert in predator-prey. I could have picked chemical equilibrium, but that's my area of expertise, right? So then I know all the variables involved very easily. So it's not going to be like I thought I'd pick something that I sort of like was a novice in. So I'm a novice in predator-prey. I'm not an expert in it. It's not my background. So, but it allows us to then generate a conversation and talk about what else really needs to be in there. And why isn't my death rate of my rabbits, why isn't it influencing what's going on, right? Because I shouldn't have a very high rabbit birth rate. And then just by increasing the death rate a little bit, I get to zero population. That makes no sense, right? So there's one of these variables or several of these variables could actually be tweaked, modified to make them better. So I thought you raised some really good points related to the whole notion of how to modify a model. And that's why I gave you the link I did. So I shared the link with you because if you want to add to it, I would really encourage you to try to add and fix my model. And we're going to be together on Wednesday and Thursday this week talking about interactions. But the last day of interactions, maybe towards the end of the period, when we have 10 minutes or so left, I'll see if anybody has actually, I'd love you, if you do this, I'd love for you to send me your model and then I can share, tell me you did it. I can look at it and then I can actually share it on Thursday after, we finish the interaction session. Anyways, I hope you picked up a little bit more about building dynamic models and the idea that there's actually flows, and that one of the most important aspects in a dynamic model is that they actually do have feedback, right? So I could, for instance, just I don't know if this is going to do anything, but an increase in the number of rabbits dying causes death rate to increase, and I'm gonna say about the same. And of course, I could go here and I could do the same thing here. I could say an increase in the number of rabbits causes rabbit birth rate to increase, and about the same. And again, I don't know if that's going to make a difference in my model. And of course, one of the things you'll notice now that the only thing I can modify is my birth rate. So something's wrong. I did something wrong, right? So that's not how to build this model, because now I wiped out any wiped out any dependent variable that I can change. There's nothing I can change. So I can't do that, right? So right away, I learned I made a mistake. So I'm going to go delete those. So at least I have something I can control. Okay, so with that, I'm going to actually pass this off to Ann. If we get time, I'm actually going to come back and build another model, but I do want Ann to focus a little bit more right now on static modeling and building a water quality unit, because that'll really help gel the water quality unit, as well as really gel our development of building models. And of course, I will be here as well. And if you have questions for me or Ann, I'll be here doing that as well. So I'm gonna now stop sharing, and I'm gonna pass this off to Ann, and Ann can open and share the PowerPoint.
Oh,
Unless you want me to do it and click
yeah,
through
you
it.
can do it.
Okay, I
have
will
it.
click through the PowerPoint for Ann. So I'm going to share my screen. And hopefully we'll have time to build the effectiveness of a virus in somewhere along the line. And so now we're going to go develop a model of water quality. You just have to tell me when to click forward, Ann.
Okay, well, maybe we should switch.
Okay, we're going to actually
Yeah, let
switch.
me just give you okay.
Can you
So,
open it up real quick?
uh,
I'll just click, just tell me when to
Okay.
click.
Go to the next one. Can you scroll that up so I can see what's next? Okay. So can everyone hear me okay?
Maybe you should go on your machine.
What do you mean?
I can
On
stop.
mute? Okay.
I'll stop mine. Okay, okay, so
Okay, can you hear me okay, everyone?
yeah. Okay,
So.
I actually think you should download and put this on your machine.
Okay, so take a minute break and let me.
Yeah, Ann's gonna I think it's gonna be easier for Ann to sort of click through it, so just give us 1 second. I'll see if anybody has, I'll just keep my screen up here on dynamic modeling a little bit. And while Ann,
I don't have the latest one.
you have to go down, okay. Just a second, everybody. I have to just go email this to Ann.
while we're doing this, would you in the chat put what kind of variables do you think are needed to create a model for the water quality? So based on what we've been doing, so just throw your ideas in the chat. What are the variables? Did you send it?
Okay, so now I sent it.
Okay.
Okay, I'll just take a minute here till Ann. We have one variable, we have temperature. What other variables influence water quality? Do you have it right now?
Thank you.
Yep. Okay, so Ann's gonna open up and share her document right now.
I think I need to do this.
It's up to you.
As I would say, my students, when I had to teach on Zoom for a year, thank you for your patience. Okay, I see temperature, pH, turbidity, conductivity. Awesome. Okay, why isn't it sharing?
You have to share.
Nothing's happening. Let me go out,
What do you mean
go
nothing-
out.
what do you mean nothing's happening?
You have a share
Do you have a
button?
share button?
Right there.
Oh,
Buren,
Buren, I think you have to
allow
allow
Ann
Ann
to
to share.
She already musical host as well.
There, nothing's happening. You see that?
Okay, I'll share my thing again and Ann will just use my computer and walk through it. We apologize. I'm not exactly sure. I think everybody can see this. Is that correct?
Okay, wait a second. I
Yes.
gotta restart.
Here, Ann.
Share. Okay, yeah, I don't know what happened to my computer, just kind of died. Okay, so hi, everyone. As Joe said, in terms of middle school students, the static modeling may be more appropriate for their age. And so we're going to look at how healthy is the water for fish and other aquatic organisms. We want to build a model. And of course, we're going to plan, build, test, revise. Did you just do that or did I?
I didn't touch anything.
Okay, so the first thing we want to do is generate with students, like what are the variables, the independent and dependent, and the water quality, how healthy the stream is dependent on those water quality tests. We want to do the relationships between them, like you're familiar, and then the various water quality, all the variables. And so you've identified some. So when students create a model, this will be kind of a base model. And the water quality or the fish population or the amount of water quality. So, you know, to be a variable, it has to be able to change. So the way this is put in as pH, conductivity, turbidity, dissolved oxygen, and thermal pollution, all impacting the water quality, isn't really telling the whole story. So we really want to emphasize to students that it would be the amount of thermal pollution, the amount of dissolved oxygen, right? The level of pH, the amount of dissolved solids, et cetera, and that those are going to impact the water quality. So this would be like a base model. And the timing of when students create model is really up to the teacher. So one option is after the first water quality test, pH, to introduce modeling and have students create a model based on how the pH would impact water quality. Or you could wait and do a couple of them, like pH and temperature. I have done this, I have had students create models over time. But another option, which I've also done, is at the end, if I focus on various explanations over time, at the end, I have students create one model, and it helps them engage in the ideas again, and then also seeing more relationships within each water quality test, but also between the various water quality tests. So there are different options to do. So just a quick reminder that experts determine water quality by testing various water quality parameters, and that each test provides a little different insight. And then putting them together, we can really then address this question of how healthy is the water for fish and other aquatic organisms. We're going to put you in breakout rooms in just a couple minutes, and the next several slides can help you with some of that background information, right? So for pH, is the water acidic, basic, or neutral? Most organisms need a neutral, or basic organisms die. And also, we want to focus on what people do on land, and people use a lot of products on land, and cleaning supplies that are often used outside tend to be basic. Temperature, looking at thermal pollution, there are several causes of thermal pollution, and then there are several consequences. All this information is also in the student readers, which I believe you have. Let me know if you don't. That the conductivity is really measuring the amount of dissolved solids, mostly nitrogen and phosphorus, and then salt in climates where road salt is used. And there's some background there. So we want low conductivity. Dissolved oxygen is one of those tests where we really want high amounts of conductivity because fish need, oxygen. Fish need oxygen to live. And so these are some of the background slides. And then turbidity also, it's when particles that don't dissolve, those suspended particles are in the water. And then some of the causes are on the left side and some of the consequences on the right side. So you're going to use those slides to help you. And what we want you to do is we want you first to plan out the model. We want students to plan and then do some building. Choose a picture to represent each variable and then label that picture. And then we want to stress to students, it's not just, temperature, right? It's the amount of thermal pollution, the level of. You're going to identify relationships between those variables, and then specify increase, decrease, vary. And then this one, the degree, the same, a lot, a little more and more. This is an opportunity to actually work with math teachers to see, where students are in terms of understanding these kind of graphs. So you might be able to, a math teacher and a science teacher could really complement each other's curriculum, or at least you could, teachers can ask math teachers like where kids are at in terms of their understanding. So these might be new ideas to students. They might connect directly to what students are learning currently in math, or they might be something that students will learn in future math classes. And then it's really important to complete that because text box. This allows students then again to revisit the ideas, to think about the relationships, et cetera, et cetera. So this testing to run the model to see if it works and to revise, Joe talked about that as debugging, right? But so, the model has absolutely no science. This is actually, kids find this very exciting. And my experience at least has been that the students love this program and they enjoy building models, but they find it really as a nice challenge to know that there's no science in this program at all, that they're the ones that have to put the ideas in and then test it and then revise. And so this idea of fixing. So I highly encourage this cycle of building, testing, and revising very regularly, not to build and build and build and then test, but to build something and test it. see if it works the way that you think it should work. Okay, and then testing and evaluating, and then expanding the model. The other thing is in terms of sharing the model, when students share their models with other students, I have found that to be extremely valuable. You know, kids teaching kids, both the teacher and the student really develop a deeper understanding when it's done that way. So the sharing. Okay, so these are some of the things that we would start with our base model. So this is where we want you to start. And once you get your base model, then there's things that impact each test, right? So pH is dependent on various factors, as is thermal pollution, right? So students can expand their model. They can start with a base model, and some students may only get to the base model. And other students who are brighter also are challenged. So this is a nice way to differentiate in classrooms, because all learners, no matter where they're at, can do a version of a model that's meaningful and helps them develop understanding. And so when you're in your breakout room, if you finish your base model, then you can add like the second layer, which it talks about, you know, all the factors that influence each of the tests. So we're going to put you in breakout rooms, and we want you to spend time building a model. You can go back to those slides that have some of the science ideas. I'm going to be visiting various rooms to see how your work is coming and answer any questions, but don't hesitate to, you know, invite me to come in. But you're going to talk and work with people in your room. We're thinking about 30 minutes, but we'll see how things are going.
Maybe 25 though.
Okay, maybe 25. But before you go, do you have any questions? So, Baron, if you could make some breakout rooms, 1, 2, 3,
Yeah,
4.
sure. So will make 2 breakout room. We have small people. Okay, I'll start this right now.
Okay. Great. Thank you, everyone. Let's see. Computer.
Okay, so why don't you log in?
1 second.
Fish. Fish population.
Only
Maybe
one.
fish.
That's the whale.
Yes,
Okay.
yes. Maybe fish.
Maybe just fish.
Fish, just fish, maybe. Ah,
Maybe fish in the water. Like it's
yes.
mean the same thing.
Seems-
Okay. No, no, no. Do you like any of them?
Yeah, yes. Ah,
Okay, let's go.
Sense. How about the
What
suspended
about clear,
particle?
clear? Huh?
This one is refer to the
Yeah.
turbidity,
You have any
right? Yes,
questions?
just
No, and we just select the image that relate to the variables.
yeah. Or
So, can you hear me?
it's the
Sometimes
same.
if we just write down turbidity, then there are no image provide. So we have to think
Yeah.
about clean and or maybe clean or dirty
Dirty water, right?
dirty water. Yeah.
Dirty.
You're doing turbidity?
Yeah. We just
Yes.
want to find image first.
So even just dirt and you get like a dirt pile and that could be,
Dirt.
Yeah.
Okay. Yeah.
Okay.
Dirt.
That one.
so this is one thing students can end up spending too much time on because they think it's so much
Yeah.
fun. So one thing I stress is, find those objects, spend a few minutes, and then, but it can be because, students love this stuff, right? So is this your first variable you're
Well,
putting in?
Yeah, for example, for pH, we cannot find image, so we just select lemon.
Yeah, that's what I was making a model yesterday too. In the, excuse me, in the past, when I would put pH in, a pH scale would show up, but that's.
Oh, okay.
I went through all the images, and I couldn't find a pH scale, so.
Yeah. So
I-
and for our task, we have to design the static model for the main variables. Then we have to create the relationships, and after that we have to think about the second layer of variables, right?
Right, so I would first just try to do the base model with the 5 water quality tests and their impact on water quality, and do all the relationships and everything for that first. And then see if there's time.
Yeah.
Okay, so you look like you're working to set up your images and things, so unless you have questions, I'm gonna go to the other room and then I'll be back in a bit.
Yeah, thank you, Anne.
Okay, thank you.
Can you just
You're welcome.
choose the image of oxygen, the red one, red with 2 molecules, or this one? Yeah,
Yeah.
that one. Okay.
Okay. Yeah, so for now we have the picture of a
Yeah.
pH.
Let's try to write down and draw the relationship. First, we have to show this one is the level of okay. Here, the arrow, okay.
So we
Yeah.
choose this one.
Oh, okay. Oh, maybe this one. Yes.
This.
Yes, oxygen.
Okay, so
Okay.
oxygen we have turbidity. How we can? What's the synonym of turbidity? Maybe we can choose another term. Thermal pollution, various. So that's this supposed to be. Pandu, could you please find out the synonym of turbidity? Maybe we can like look for something different. Quality fish population. That's gonna be the first, and then we have the thermal pollution. Thermal pollution, and this is the dissolved oxygen.
This oxygen. Oh, okay. Turbidity is maybe like a solid dissolved in solution. Are either organic or inorganic substance. Oh, what is? Yeah. Solid in water. Yes, because is scientific is difference in research in
The conductivity.
on
Mm. Let me quick. Turbidity synonyms. Ah. And we have a problem with the like finding right icons. So like the how we can paraphrase the pH. So if we would type the pH, we don't hear you, unfortunately. You're mute.
Okay, so there used to be one where I put pH and the pH scale would come up, but I can't find that now because I was using this the other day. So you could pick a lemon, you could say chemicals and use something like that. You know, because you're going to, you know, when we think of lemons, we think of acids and that doesn't cover all of pH. But so you could use a lemon or try putting in chemicals and see what comes up.
Chemical, like this?
So if you wanted something like a, you know, test tube with something and put acids and bases, so it's up to you. So that bottom left one, it could be, right? One thing I do stress to my students because they could spend most of their time having fun finding pictures that they like is to say, you know, you, to try to just, you know, quickly find something and then you're going to put text under it, right, to clarify what it is.
Uh-huh. And
May not
and turbidity, the
exact-
turbidity.
Yeah, so for turbidity, I might just put dirt and then pick something, right? That's a very common thing that floats, or it could be algae.
I
if
was
you like,
trying to
right?
find
So-
out some synonym of turbidity. Maybe like a no. Maybe something.
So you know it's under, there's like more than 5 pages of ideas, right?
I see.
But you just need something to represent the water quality test. Sometimes you'll find like temperature, that's an easy one. There's thermometers, right? The students can also get pictures from other places, but then they just spend their whole time doing that. So I tell them they can only work within the program, but you could search outside, download pictures.
Maybe like a unclean water, like a show the turbidity. No. Unclean. No.
Yep, unclean or dirty water. The challenge of showing kids how to go outside is, again, they're going to spend all their time finding pictures and not thinking about
Like this.
sure,
Well,
right? As long as you label it, right? Dirty water, so, you know, or
Okay.
yeah.
And the what was the last one? The conductivity, something.
Yep, so you can look at like dissolved solids for conductivity. And then there's now see this like generic picture comes up, or just dissolved, put it in and see what shows up. So, you know, so the one I picked was on the right there because it's like something's going in water and it's dissolving, but you know.
You mean the glass one?
That, yeah, that's an option.
Okay, we will. I think we don't need to waste time, right?
Right, as long as the text then clarifies it when someone's looking. So, and then oxygen, turbidity. So if you click on that arrow under the lemon, if you click the arrow, because yeah, but it looks like if you have everything in, and then the turbidity, and then the 5th, and oh yeah, okay, so you'll have everything.
So probably one of the easiest ways you could do it is you could find an image of pH scale on the computer and you could copy it to your own computer and you could just send it to the kids. So the kids could have it on their computer. And then you could easily.
Oh, I see. So there are options like on my computer in when we upload it, right?
Right. So if you look at it, you'll see for images, you can see my computer. I can't, the link one, when if someone could go search for an image, I'll just show you something really quick.
So new image on the top left.
Yeah, go to new image on the top left. Right, and say, so you see the link down there?
The third one. Yeah.
If you click on link, that doesn't really work. At least I can't get it to work well. I'll keep working. I think the best thing to do is to find one, save it to your drive, your own computer, and then you can upload it.
For students.
Or your students can upload it, yeah.
Okay, so, all right.
Although I found that they want to get their own pictures. But,
Well,
yeah, I know.
it helps to contextualize it actually.
Mhm. Yeah, they used to have like something like this.
So I
in-
like
in
this
there. It's
one a
not-
lot.
Which one?
This one. Because it's got the different kind of things.
Yeah.
Anyways, I'm gonna try that. Copy.
Okay, so now you have the variables and you can start, making relationships with them.
Uh-huh. No. Here we go. So the main, this one, so this software should like this.
Mhm.
And
So now click on that, on the line. Okay. So what did you
Uh-huh.
say, an increase in dissolved oxygen?
so it should show the positive, right?
Mm-hmm.
Like, oh, you know, okay. About the same, a lot, a little, more and more.
Yeah, so this is where, students aren't sure, so they would put one, it wouldn't be less and less, right? So it would be one about the same a
Mhm.
lot, and then they'll try it and see if they like it.
Uh,
They'll go back and then they can fill in the text box. Why do you think so? Right? And then they get to use the science ideas as they're building their model. Right?
Oh, should we choose the, no, we do the static, right?
Yes,
Not
so can you
dynamic.
stay in that one? So if you click on that toggle again, if you go back to the bottom right where you just were, okay. So if you scroll down, under view settings, see where it says show relationship symbols? The very that one, click on that. Okay, and
Uh-huh.
now you can put it away. Now, if you go back, you can put that away now. Now you can see, do you see a plus sign on that
Yeah,
line?
yeah.
Yeah, so if you do that, then they'll show if it's a positive relationship or a negative relationship. So
Yeah,
I
yeah.
like,
I know the blue is like a decrease, right? So red color is increasing, the blue one is decreasing. And
yeah, which
then
I think is just I think it should be the opposite. I think red, yeah, okay.
yeah, I was thinking so, like a red all the time refers or stand out for the like a negative something.
Yes,
Yes, we totally agree with that. We've had big fight about this as a development team, but
yeah, it's intuitively, it's
nothing we can do.
backwards. We've tried to argue with them, but
So this model is much easier than the time-based, right? Because like there are
Absolutely.
like only, because in time-based it's a little bit complicated.
yeah, so
Okay.
You could build a time-based one with water, and I was hoping if we had time, we could do it, but maybe later on, I could do it for everybody once we get involved in some of the other units. We have some of our consulting sessions, maybe
Yeah.
we could try to build a time-based water quality model, but
yeah, and that,
it does get much more complicated to do it.
yeah, and that could be appropriate for high schoolers. For middle schoolers, it gets very messy and confusing. Okay, so you look like you're in good shape.
Oh, yeah. Ah, yeah. Yeah.
I'm gonna go
The-
visit.
Way here. The same. So pH. Turbidity.
Less fish or
The more.
Yeah.
The more level of pH.
Mm.
Less and less. How do you think it? Less and less the number of fish survive.
Yeah.
So, okay. So, and then what? So, it will live here, or I just
Yeah,
put
just leave,
enter?
and then go to temperature or other things.
Okay. The degree of temperature.
Click and drag.
Okay. Yep.
And now you can click right on the line.
Yep.
Okay.
Okay. Increase the degree of temperature cause the number of fish population increase temperature. The number of fish is also
Decrease.
decrease like a lot, more and more,
Yeah.
a lot, right?
Let's check. They will show us the graph. Okay, the degree of temperature increase, and the number of fish will be decreased. Yeah.
So if a lot, the graph will be
Like that.
yeah, like this, which means that no fish survive at the end of a certain pH. Oh no, temperature. Yeah.
The water is boiling.
Oh no, decrease more and more. It's still like that. Yeah. So then we choose a lot, right?
Yeah, a lot.
Yeah, a lot. Okay. So reasons. Why do you think that?
So filling in those text boxes really allows students to then revisit the science ideas and talk with each other. And then they can test it, and if it's too dramatic, they can adjust it, right? So it's very easy. But one major consequence of thermal pollution, if it gets too hot, fish just die. Like that's what I would think students would put in.
Okay, so even temperature is too hot.
So we're hoping to give you about 5 more minutes. We know it's not
Okay.
enough time.
Okay.
Keep plugging away, or it looks like you're making really nice progress.
Okay. Okay. So
Then level of transparency or turbidity.
okay. Sure.
Okay. Then relationship.
Increase the level of transparency, which
Mhm.
means that it's more clear, right?
Yeah. So the number
Yeah.
of fish will be increased too. Increase.
Yes. Okay.
More and more.
Reason.
Select an option. More and more.
Oh, more and more. Okay. Okay.
More clear, more fish.
Really?
In my opinion, more clear, and then more
Okay.
easier for me
And
to
then
fish.
more fish. Okay. Oh, it's look scientist. Okay. Okay. Sure. Next one.
Clearer than easier to catch the fish.
Okay.
Then level
Level.
of dissolve. So if the level of dissolved oxygen increase, then
Increase.
more fish,
Okay.
right? More and
More
more.
and more. Okay.
More oxygen, more fish. Oh, I think it's more oxygen, more fish. Okay. Right. Yeah. This one is
Increase population of algae cause the number of fish
decrease.
decrease, right?
Less and less. Is it correct?
Okay.
So it means that population of algae increase, the number of fish decrease. Yeah. More
Yeah.
algae, less fish.
It seems like it is not a reason, right? because we just rephrase what
I-
appear in the graph. Okay.
Now I just follow the way of Joe.
More algae. More algae. Less fish. Okay.
More algae means how to say, less oxygen,
Yes.
Yeah.
less oxygen, and then less fish.
Okay. Can
That's the
cause can cause less
oxygen.
oxygen. And then
So let's check the relationship. The blue one means decreasing, right?
And cost.
then cause.
Yeah, less fish. Okay.
Okay.
The blue
Okay.
mean. So is
So
it
how about the second
layer?
layer of this? Yes.
Yeah. pH
just-
is depends on the plant surrounding the fresh water, right?
pH.
Plant. Maybe you have to find the plant. And also, just choose one. The brush. Yep.
How about this one? How
Yeah,
about
yeah.
this one? Yeah.
Then, not only plant, but also the what is it? The disposal from house or from industry.
What kind of disposal?
Waste. Chemical waste from industry, or for example, from your house,
It's just like organic waste or
detergent, and where car wash, anything can
You
make
mean that the household
the pH
household
change,
waste?
right?
household waste?
Yeah, just take number.
You mean that like the detergent, right? That it will
Yeah,
make
a lot of
water waste.
detergent. Yeah.
Yeah. How about
Where anything.
this one?
Yeah, it's okay.
Yeah. Okay.
What else impact the level of pH?
Is the chemicals leaks from the
Household?
factory? I mean the factory nearby
So-
the
So, H.
yes. Chemicals. How about this one?
Is it acid? I mean, the rainwater also influence the pH level?
It's not too much, I think, because it's the
But-
amount of the
Yeah.
sea water is
But I think rain will be make
breakout
water-
room is gross. Okay.
just leave it. But I think the rainwater will make the pH will be going to natural, right?
Yeah, it should be.
Yeah, so maybe we just put also rain or something.
Rain.
That everyone? Okay, so we know that you didn't get enough time to fully develop your base model. But we would like each group to share what you have so far and kind of explain your model. Just take a couple of minutes. So is there a volunteer to start us off from one of the groups?
Two, are you ready, Nim?
Go ahead.
Oh yeah, sure.
Okay, could you please share the screen? Okay, so this is our result of discussion. So we put the the variables first, degree of temperature, and then level of transparency. It means related to turbidity, level of dissolved oxygen, population of algae means the conductivity, and then level of pH. And our independent variables in the number of fish or fish population. So here the first layer, we think that if level of, we have to assume here that pH is natural. Then if level of pH increase, it means the number of fish population will be decrease.
So can I ask you to
Yeah.
hit your simulate button on the top right, the simulate? It's way over here. It's on the top
Name
of your,
in the touch in up, there is
Up.
simulate. Can you click?
so click that button.
Yeah, that one.
Yep, click that. Okay, so now you see the, what do we call these? I can't never remember.
Okay.
So if you want to just do what she said, right, as in temperature, if you said temperature increases or pH,
Sliders.
the sliders.
Yeah.
So let's try that, and see if the population,
Yeah. So first, if we look at to the level of pH increase, then the number of fish will be decreased. Going up.
so you can set your other sliders to, yeah, okay, so it goes up and then it's, so,
But-
so is that working how you want it to work?
Yeah.
Okay.
Wait. This one is level of Nim. Could you please go down and then slow. If level of pH, for example, low, and then we go to the mid, go up.
And
Yeah.
can you click on your blue relationship line? Can we just see? And then go to the arrow on the far right. Okay. And so we can see it decreasing. And when we get to the next group, they're going to show what they chose. Okay. Do you want to pick one or two other variables and talk about them?
Yeah, and the other variables is the population of the level of dissolved oxygen. It means that if the level of dissolved oxygen increase, it means more fish or more organism will survive in the water. So the number of fish will increase too.
Okay. Very nice. So I'm going to ask you to unshare and then have the other group share their model.
Yep.
Thank you. That looks great. Okay, so will someone from the other breakout room share?
I guess we were only two group, right? So we
Mhm.
unfortunately spend a lot of time to choosing the icons. So, and we just build up relationship. And I was asked to share the pH, right?
Mhm.
So, but we didn't have the chance to simulate. Do you want me to simulate it right now?
Do you want to show the variable that you chose instead of going increase or decrease? Do you want to click on the relationship first?
So you mean this one, right?
Yes.
So as we know, the pH differs in different water. So, and there are like acidic, neutral, and basic pH. And so we kind of show it varies. We draw this graph. Is a graph, right?
Mhm.
So this graph, it looks like as a mountain. If we will simulate it, it's supposed to show this kind of graph. So should we see it?
Sure.
Okay, so the continuously or just for
So
once?
you can just move the slider on pH up and down.
Right, so you could make a couple of predictions based upon your graph, right? So you know if it goes down, water quality should decrease. So we can look at your water quality and see what happens when you move it down. And you'll see that it moved down a little bit. So we got to fix it somehow again because it's not told. And as we move it up, again, it should get to a good spot, but then if we go really high, it should go back down again, right?
So
So we have to work at just a little bit to figure out what's going on.
so how we can change it?
Well, actually, before you do that, right now you could put the other 4 variables at their best. So the thermal pollution one would be low,
Oh,
and then dissolved oxygen would be high. And then turbidity would be low, that's the best, and the conductivity would be low. Okay, so now we know those 4 variables are set to be the best they can be, and now we can test the pH one again.
huh.
Okay.
But
So that didn't change.
No, the reason why is because each one of these are impacting at the same weight.
Right.
And when it impacts it at the same weight, just because you're changing one and making it bad isn't going to impact all of it.
Hmm.
So you have to,
So if you go,
there is a way to change that, but in 3 minutes, we're not going to do it.
but if you click on the far arrow, it more and more over to the right, what do you call this?
The relationship
The
arrow?
relationship arrow. Okay.
Uh-huh.
So you don't get to put here more and more, it varies.
Yeah, well, one of the ways she could do that is one of the ways you could fix what you drew is make it a little bit more gradual and a little bit more of a hump at the top. So rather than as a point, you want to make it more of a hump. So that would help,
Yeah,
right? That would help too.
Like this?
It'd be my guess.
yeah, let's
Yeah.
let's try
See what
that.
that does.
Okay.
Okay, so it's
Yeah.
moving a little, yeah. Okay.
So it changes a little bit. But in fact, if you get a pH of 0, you should have,
Death.
yeah, you should have absolutely, it should be the major factor in your stream. But if you click on it, if you go to the, I have to, if you go to the settings,
The toggle thing?
no, the settings button, click on it. And see where it says limiting variable, that's what you wanna click on it.
Yep, right,
See where it says limiting values?
right there, yep.
That's where
This
you
one?
build, right, that's gonna be, you're gonna wanna play around with it. So now click on the pH,
Uh-huh.
but just click on it.
No, I think
And I
it's,
think you can play, you're gonna have to play around with that a little bit.
no, I think
And if
it's,
you send me your model, I'll play with it
Okay.
as well.
but I think it's because you also set it 0 to 14 and everything else is set 0 to 100, and so it just doesn't.
That's correct.
It's so.
That's what I mean, you have to set the
right.
variables.
So if we didn't do that part, then it would be more dramatic. Okay, we're
Ah,
almost,
I see. Uh-huh.
yeah, so, right, so if we just set that back like everything else, then it would be.
But we didn't change here, right?
Mhm.
Right, so make the pH back to 0 to 100, and my guess it'll work
Yeah.
fine. Well, not fine, but,
It'll work the way you think it should work.
uh,
Mhm.
you have to change that to 100.
Mhm.
Yeah, no, and then
Here.
put that at 50, yeah, put
50?
that at 50, yeah. And now what happens? No,
At
we still
50.
got.
Why I can write the 50?
Yeah, that's not going back. That's weird. I don't know.
Well, because it's a free program.
Ah.
Okay.
So
I
if
think
you, yeah.
I have to go.
Yeah, if you unshare, I'm just gonna quickly show you what I came up with, which is very similar to what
Okay.
you.
Stop share.
Because we're just really out of time, and so this is the model that I created. So I have very similar things that you do, and when I simulate pH, right? So so you can see I'm going up, it goes down, in the middle, it's high, and then it goes down again, right? Because I actually have thermal pollution. So I kind of like the sliders because at the end, my students can take what they actually got for their results, and they can set the slider to where that would be. And then this would help them with an overall claim in terms of the water quality, right? So if they got neutral pH and no thermal pollution and high oxygen, and then very few dissolved solids, right? High water quality. For us, we always get a large amount of dissolved solids. So, students can play around with this, but you can see the models you were building are very similar to what I built. And then, with more
May I-
time. Yes.
What's the settings to your pH?
So I put, where's the pH? So I put vary, and then I left it at 0 to 100, like we just did. So that's what you can draw this in. And then another thing that I told in one group and not the other is you see here that there's a plus and a minus, right? So oxygen is a positive relationship with water quality, and the other ones are negative. And you can get those by just clicking here, show relationship symbols. So I took it off and I put it on. Joe and I have been talking to them forever to say the positive shouldn't be red, but they're not going to switch it. It's too embedded in there. But you get a sense in terms of building, and then kids can build out from each of these. Now, anyway, we're out of
Again,
time.
it's not a perfect tool, but again, all models have limitations, right? So, and that's an important message to send to your kids too. They're gonna struggle with building some variables or some models, but on the other hand, it gets them engaged and really looking at all these various factors, et cetera.
I would say also one last thing. There is a relationship between the amount of thermal pollution and the amount of oxygen, right? Because warm water can't hold as much oxygen as cold water. And so this could also, show there's a relationship between floating particles and temperature, right? Because particles in water absorb heat. So hopefully that they can see that these 5 water quality tests aren't silos, they're not all separate, but that they do connect with each other. So the models can get more complex as students get more experience and then can think more deeply in terms of the science. Okay, so we're out of
Yeah.
time. I know it's late.
I
for
have
you.
question, Anne. When
Yes.
you apply the model to the students, did you also guide them to do experiment from, I mean, are there any specific guide to have the experiment 1, 2, and 3, and or they just randomly do or move the slider among the variables?
So there's a lot of options. So depending on time, so the minimum I like them to do is move the sliders and see if they work. But then they can run their model and they can see on the graph so you can run a model to go like 100 seconds or 100 times. And then while it's running, they can see on a graph, they can change the variable and they can see how the data table is shifting. For the graph, you can only do 2 variables at a time. So they would have to say, okay, I'm going to look at how oxygen, right? So the dependent and independent variable. So for me, I think they can test those parts with the graph, but to see the full picture, because there's so many variables, to me, just to have the 2 at the same time is not as valuable as seeing the whole model and seeing how everything shifts as you move various sliders, especially if you connect like the temperature with the oxygen and the turbidity with the temperature, right? So everything so in that sense, as they're moving it, it's dynamic in that it's moving, and they can use it as a prediction. What happens if this goes up? How does it impact the entire system? So they can see it as more of a system instead of separate water quality measures with the water quality. Okay.
So we'll be back Anne will be back next week where we do the first PD planning, and we can also ask, because it's PD on water quality, we can certainly ask deal with these questions then as well.
Mm-hmm. I'm
So-
introducing this today in my classes, today and tomorrow.
So I have to run the work, so I'm gonna sign off, and everybody have a pleasant night, and then I'll have a pleasant, hopefully Ann and I will have a pleasant day at work.
Yeah, bye-bye.
Bye-bye.
Thank you.
Yeah, bye-bye.
Okay, thank you, Joe. Thank you, Anne. Thank you, everyone.
Bye.
Bye-bye.
Have a good day.
Thank you.
Yeah, have a good night.
Thank you.
Bye.